center of this bridge. And so you can design for one or the other, or maybe what you want to do is looking at both loading categories, one at a time. I'm going to stick with the standard loading for now. And again, the help screen will give them more information about that if they're interested in what's going on with it. Okay? The context will specify for them what their loading is going to be. Yes? Okay. And now if I go on to next, here they get it, and I would suggest that you would encourage them in playing with it initially to work with the standard truss template. A template is a diagram that depicts a standard truss configuration. Why are these standard configurations? Because they've worked well in the past. They do a good job of carrying loads, and they're economical. Okay. In fact, a lot of these go back to the 19th century. Names like Warren and Howe and Pratt are structural engineers from the 1800s who patented these truss geometries. So then the trusses are named after them. If they select a template, it'll just be displayed in light gray dotted lines on their drawing board, and they're free to draw those joints and members to ensure that they end up with both an efficient geometry, but also one that gives them a stable design. And you want to be impressing upon them the stability. They want to stick to that triangular shape. And if I were to go through here and take a look at most of these, what these trusses are going to look like if you take a look, there is the Pratt truss, Deck truss, there's a Haldeck truss, there's a Warren through truss. What do you see? Triangles all the time. They're also free to do a free-form design. Normally when they do that, they end up with, or can end up with, instabilities in it. But hey, if they get an unstable design, there'll be a help screen that will explain to them what is happening with the instability. In effect, what has happened is they've selected a geometry that cannot hold its shape under load. Okay, it will deform too greatly. So we go on to next, and they can fill in a title block. And now we're to the point where we're ready to start designing the steel truss. And so I hit finish, and because I last had the Warren truss, notice that this is now my drawing board. I've got 1, 2, 3, 4, 5, 6, 7, 8 joints that I must have. Okay? Those are necessary to be able to get a solution. It gives me in dotted lines a suggestion, if I want to go with the Warren truss, what that's going to look like. But I am free to follow that pattern or not follow that pattern as I choose. Here are my design tools up there. Right now, if you take a look, the joint is selected. And so I can now come in here, and if I left click, start putting joints into my design. And then this is my member tool. Left click, and I can start drawing members. I need to leave up the left click button before I move on to the next one. So there's one member, okay? And now if I were to left click here and go over that, notice the difference between here. Now this is, if I were to select, I only have one member selected here, okay? And it's gone through a joint. If I leave that way, what is going to happen is I'm going to end up with an instability. I need my members to begin and end at the joints. So let me come up here and select my eraser, come down here and erase that member, go back and select my draw members again, and left click and then release to start and end the member at each joint. If you notice, while I'm building this truss over here on the right-hand side, there we go. Yeah. I am pulling up it's building a member list for me. And it gives us a default material type, which is carbon steel, cross-section, bar, okay, rectangular. Size of that bar was actually square. It's round, 160 millimeters in diameter. The length of the member And then it will also provide, if I pull this over to take a look at it, it also will provide for me when I run a load test, it'll give me the ratio of the compression force to the strength and the tension force to the strength. Talk about that a little later. Yeah.
Yeah, just the difference in the newer versions of the slenderness ratio that is on the 2007.
Yeah, there is the slenderness ratio is given on, and that is related to members in compression and are they likely to buckle or not. Okay? Yeah, and what I'd like you to, I think that most of them have started doing that. If you have it already, start building your own truck. Start building your own truck. Yeah.
That's funny.
Well, what do you want to do? You need to put your joints in first. So select the joint tool. And yeah, you look at where you're putting your joints. Notice you have to have those that are solid. When you get dotted ones, you follow the So those you're not going to build joints over top of because there's already a joint there. Like right here. You can put a joint there if you wanted to. Yeah. Or you can follow. Other questions? Let's get our joints and members built. So get yourself a geometry built, and then we'll talk about what we do from there.
You build an Eiffel Tower.
Oh yes, the students love to build very complex trusses, and then when they look at the cost and it says $2 million, they're shocked.
$2 million.
Trust number one.
Remote control is more than all the ones.
You can add extra joints in there and you can add little things.
That's pretty cool.
That's why it wasn't letting me put it.
So now what do you have? You're running back to the drawing board. Right. You can go back and start it over again. Well, see here, it's telling you what's in tension, what's in compression, and that's where it fails.
Can't support their own weight. Then you got to go over.
Yeah. If you change number one, chances are this part is right, so if you go by that one, well, that one is reading out that it's amazing 22%. So you can definitely change it. And that's all you really do, just kind of keep it like that. And there's a lot of other things you can show, like if you want to see all the trusses first, just look at that and remember all of them. There's like different grids you can have behind it.
Otherwise, you're done all the way to connect them individually.
I want to go back to the designs and pick a different.
Oh, yeah.
Yeah, we're in